When working with an individual value from a normally distributed population, we use the z-score formula x bar minus mu over sigma. When working with a sample or a group and not a single individual, we use the z-score formula x bar minus mu over sigma divided by the square root of n. The square root of n being the big difference between a single individual and a group of individuals. So let's look at the first question. The lengths of pregnancies are normally distributed with a mean of 268 days and a standard deviation of 15 days. So we know that our mean is 268 and our standard deviation is 15. So now we're going to look at the question. If one pregnant woman is randomly selected, find the probability that her length of a pregnancy is less than 260 days. So we know that our x bar is going to be less than 260. Once we have all information, now we're just going to plug it in and find our z-score. And since it's a single individual, one woman, we don't need the one with the square root of n in the bottom. So z equals 260 minus 268 over 15. And when we get our answer here, we're going to get a negative 0.53. And now we're going to take our z-score and use our normal CDF in our calculator. So normal CDF. And since we want less than 260, we want less than negative 0.53. So I'm going to pick an arbitrarily large negative number. So negative 9999. And then the negative 0.53 will be my upper 0.53. And now that I got all that put in, I'm just going to bring up my calculator and we're going to let it do the work for us. So second and vars, normal CDF, negative 9999, comma, negative 0.53 for my lower and my upper. And I'm going to get 0.2981 rounding up. So our answer is going to be 0.2981. So the probability of a single woman being selected that her pregnancy is less than 260 days, 0.2981. Now, if 25 pregnant women are randomly selected, find the probability that their lengths of pregnancy is less than 260. So again, we need to know our mu, which does not change from the previous part. So 268, our sigma, same, 15. Our x bar is still going to be less than 260, but this time n is our group, which is 25. So if 25 pregnant women are randomly selected, find the probability that their lengths of pregnancy is less than 260 days. So we know all of our values, and since it's a group, we're going to use the formula with the square root of n. So again, going back to our z-score formula, z equals 260 minus 268 divided by 15 over the square root of 25. And again, I would recommend doing piece by piece unless you're very confident plugging it all in one time. For the top, I'm going to get a negative 8. And the bottom, I'm going to get a 3. And that's going to end up giving me a z-score of negative 2.67. So there is z. And now I'm going to plug this into normal CDF just like I did with part A. So normal CDF. And since we want our x bar to be less than 260, we have to be less than negative 2.67. So pick a large negative number, so negative 9999. And then my upper is going to be negative 2.67. And I'm just going to plug this into the calculator. So second vars, normal CDF, negative 9999, comma, negative 2.67, close, and we're going to get an answer of 0.0037, round that up to an 8. So 0.0038. So the probability of selecting 25 women that will have a pregnancy lasting less than 260 days is 0.0038. So again, here is the comparison between a single individual, a single woman that has a pregnancy lasting less than 260, and a group of women, 25 in this case, having a pregnancy lasting less than 260 days.